Hello friends, we will be discussing communication technology for smart grid. Now in previous slides we have already seen many other communication protocols and techniques which is being used. In this section we will be dealing with GPS, so that is Global Positioning System. Now officially the Global Positioning System was a different name was given, which was Navstar GPS, and this name came from Navigational Satellite Timing and Ranging Global Positioning System. So initially we had a Navstar GPS, which later on was modified and it was known as Global Positioning System in the form of Global Navigation Satellite System. So it was first developed by a United States Department of Defense. Now how it works, it consists of actually dozens of GPS satellites in the medium Earth orbit. The region of the space which it covers is 2000 kilometers to 35 and 786 kilometers. So make up to 2 dozen satellites working in unison, that is known as satellite constellation, which costs around 750 million to manage and to maintain the system per year. So this is mainly used for navigation, map making, and surveying. So these are the main important applications which GPS is being used for. Now, how a GPS works, it basically works on the components of GPS. We have three particular components: the space segment, the control segment, and the user segment. So the GPS working will be based on these particular three segments. Let's start to understand one by one. First of all, let's see what space segment means. So you see here in space segment we are talking about there is the Earth, and around Earth there are 24 space vehicles are rotating. So there is a movement of 24 space vehicles into a certain orbit. So there are six orbital planes which are inclined at 55 degrees to the equator. Now, these satellites are orbit of the Earth in 12 hours. So every satellite is orbiting the Earth in every 12 hours. So at a time, at a point, you can see here with the red lines, you will find there are space vehicles which are active or which could send or receive data at a time. There are 5 to 8. The constellation provides 5 to 8 space vehicles from any point on the Earth. You can see here. The visible satellites is being changing time to time, which is 6, 7, or 8. So somewhere you can understand what space segment is. Space segment is nothing but we are talking about the satellites which are in motion and the satellites which are always getting connected to a particular point on the Earth. Moving ahead, the next segment, that is control segment. As you can understand by the term control, which definitely means there are certain stations or the control stations which are being set up on the Earth in order to control the activity or in order to monitor the activity of the space vehicles. So the control segment is composed of a master control station (MCS), an alternative master control station. You have four dedicated ground antennas and six dedicated monitor stations. So these are the control segments which will be looking towards the movement of the satellites and try to monitor the data being sent and received and try to monitor their location from time to time. So the control segment comprises of five stations as we discussed in the last slide. They measure the distance of the overall satellite every 1.5 seconds. Now this measurement is done in order to send the corrected data to the master control so that they can verify the satellite position whether it is correct or not. Hence the satellite orbit or the clock performance and the health of the satellite is determined. So we can see here the control segment will always keep an eye on the satellite, whether it is in perfect healthy condition, whether it is orbiting at a particular specific time being set, and whether any repositioning of the satellite is required or not. So this information is set up to the three uplink stations, and thus the control segment will work to properly locate all the satellites. Third segment is nothing but the user segment. The user segment will be nothing. The ones who are hundreds of thousands of military users or the civil or the commercial or the scientific users which will be using this GPS system, the GPS precise position services. Now, what the user segment will do, it will receive the data and it will decode the signal from the satellite and it will then use that particular data. So what the receiver performer task will be, what the receiver will perform is selecting more satellites. It will select a satellite, maybe one, maybe two, maybe more than two. It will acquire a GPS signal. It will be used for measuring and tracking and then recovering the navigation data. So this is how the user segment will work and the scopal flow positioning system will be implemented. So these are various frequency or the bands on in which GPS works. So as you can see here, for civilian safety offline SOS signal, it has been decided at 1176.45 megahertz. Similarly, if you talk about nuclear detonation, so for that it has band L3 and the frequency is 1381.05 megahertz. So these are various bands and frequencies which are being used in the GPS frequency, that is global positioning system. Now, obviously, applications which you have seen earlier also, there are military operations applications such as target tracking, search and rescue, missile and projectile guidance. Then you have civil applications, civilian applications. So there are numerous applications such as automobile tracking or navigation, aircraft navigation can be used in disaster management or relief, or agriculture and marine application, weather prediction, railroad system, and so on and so forth. So I hope you have understood the GPS positioning system. Thank you very much.